Hello and welcome back to our programming series. Today we have an exciting topic to explore, the stack data structure. If you are new to programming or looking to expand your knowledge, you have come to the right place. Let's dive in. In computer science, a stack is a linear data structure that follows the last in first out principle. It is an ordered collection of elements in which elements are added and removed from one end, which is called the top. The other end is known as the base. Think of a stack as a stack of plates in cafeteria. You can add a plate to the top of the stack or remove a plate from the top. The last plate you add will be the first one you can take out. This behavior is known as last in first out. The primary operations associated with the stacks are, first of all, push. This operation adds an element to the top of the stack. It increases the stack's size by 1. Second one is pop. This operation removes the element from the top of the stack. It decreases the stack's size by 1. Third one is pick or top. This operation returns the element at the top of the stack without modifying the stack itself. So length is not modified in pick or top function. Fourth and the last one is empty. This operation checks whether the stack is empty or not. If the stack has no element, it returns true. So it confirms that stack is empty. Otherwise, it returns false. Stacks can be implemented using various data structures such as arrays or linked lists. The choice of implementation depends on the specific requirements and constraints of the problem you are trying to solve. Stacks are commonly used in many algorithms and applications, including expression evaluation, backtracking, recursion, and undo operation. They provide an efficient way to manage function calls, keep track of program execution context, and handle nested structures. It's worth noting that the size of a stack is not fixed, and it can dynamically grow and shrink as the elements are added or removed. Forever, there is usually a limit to a maximum number of elements a stack can hold, which is determined by the available memory. Next, we have our agenda for today's session, the introduction, the definition and purpose, the important last in first out LIFO principle, applications of stack, implementation of stack using Python, advantages and disadvantages, use cases and applications of stack. Talking about introduction, a stack is a fundamental data structure used in computer science and programming. It follows the LIFO, that is last in first out principle, where the last element added is the first one to be removed. Purpose of stack is stacks provides a way to store and manage data in a specific order, allowing efficient operations such as push, pop, and pick. Definition of a stack. A stack is an abstract data type that represents a collection of elements with two main operations, push and pop. Stacks are used to handle the data in last in first out manner, making them suitable for specific applications such as function call stacks, arithmetic expression evaluation, and many more. Talking about the important LIFO principle, last in first out. In a stack, the element that is inserted last is the first one to be removed. Each new element is placed on the top of the stack and only the top element is accessible. What do you mean by accessible? We can only access the top element. We can only operate the on for the top element. We have to enter the number, we can enter it on the top of the stack. We have to remove the number, we have to remove from top of the stack. Here is a visual example of three balls entered in stack, or you may say a pipe. First, red ball is entered. After that, yellow ball is entered. The blue ball entered the last. As we know, the last in first out, blue ball will come out first as it entered last. After blue ball, yellow ball is accessible to remove, and after yellow, the red ball will come out last. Implementation of stacks in Python. So here is the explanation of the code given in the next slide. So here is the Python stack. So we have defined a stack class. In that we have called a self.stack equal to a empty array. So in that you have got that we have implemented the stack using array. We can implement the stack using linked list. You can do it on your own. We have defined a function push self.stack.append, and we have the passed argument item. We call the function pop if not self.is.empty. Self.is underscore empty. So we have is underscore empty here, which can return the length of self.stack equal to 0. If length is equal to 0, it returns true, that is empty. Stack is empty. If length is not equal to 0, means there are some items in the stack, so it returns false, that is means stack is not empty. So if not is empty, then it returns self.stack.pop, else it returns none, because there is no element in the stack. We have a third function or method, you can call anything, def pick. If not self.isEmpty, we have to return self.stack of -1. Why -1? -1 is accessible for last element of the array. It is index of last element of the array. So last element of the array is the topmost element of the stack we have implemented. Else it return none. We have discussed isEmpty function. Now we can create a new stack object, my underscore stack equal to stack class. Okay, so push the element onto the stack. We have a push method dot push 5, 10, 15. So 5 is inserted first, then 10, then 15. So 15 is at top, 10 is at between, and 5 is at bottom. We can pop an element from the stack. At the time of pop, we have used method pop and store the whatever the returns, we can store it in a variable popped underscore item. If we print that, we have our output as 15, because 15 is at top and only top element is accessible in stack. So pick the top element of the stack. We have a variable top underscore item. So equal to my underscore stack dot pick. The pick method, it returns the top element, but not modifying the length of the stack. Okay, it just pick out in the stack. So it returns 10 as 15 is popped out. 10 is the topmost element. So check if the stack is empty. So it returns false only, because we have 10 and 5 still in the stack. So talking about advantages and disadvantages. There are three advantages mentioned here. Stacks have a simple and intuitive interface with only a few operations. Efficiency. Push, pop, and pick operations have a time complexity of order of 1. So you can see here, we have push, pop, pick function. We have only used if else statement, and if else statement have time complexity of order of 1. That's why it provides efficient access to the top element. Okay. Third one is memory management. Stacks allows for efficient memory allocation as well as the deallocation. Talking about the disadvantages of stack, there are two disadvantages. Limited access. Stacks only provide access to the topmost element, limiting direct access to the other elements. We cannot access the element which is in between or which is below or at the bottom of the stack directly without popping out the topmost. Okay. The second one disadvantages is fixed size. Some stack implementation have a fixed size. We can see that we have implemented the stack using array. Array has a fixed length or Previously only the length of the array should be defined. Okay, so it is obvious our stack is also having a fixed size, but we can implement a stack using linked list, as linked list is a dynamically typed. We can add or we can remove any number of uh, nodes or any numbers in stack, which may lead to overflow or underflow if not managed properly. Okay, so if we can have used isEmpty function, we have created that error friendly if not is empty else return none. So if we don't write else return none in pop and pick, it may give some error of overflow or underflow. There are some use cases of stacks: managing function calls and recursion in programming languages, undo and redo operations in text editor, backtracking algorithms, and depth first search, that is DFS, in graph traversal. There are applications like web browser, history management, expression evaluation, and syntax parsing, implementing algorithms like depth first search and backtracking. That's it for this video. Thank you for watching this.